All right, we're going to go estimating the square roots of non-perfect squares. So maybe we should define what a perfect square is. Some values that are perfect square are 1, 4, 9, and I'm writing square roots over them, 16. And the reason they're perfect squares is because if I look for the square root of 1, it is 1. The square root of 4 is 2. 9 is 3. 16 is 4. So these are perfect squares. I can find a whole number answer or a natural number answer to them. Okay? Non-perfect squares are numbers like 17. And it's good actually to have our list on the side here. I'm going to continue this list up. 25, 36, and might as well do 49 for a second. Okay? So we got a list of our perfect squares here. Is 17 here? Does it exist here? Can we find, is it a whole number answer? No. Where does it fall between? Kind of giving it away. But
it falls between 16 and 25.
Yeah, it falls between 16 and 25. So what we can do here is almost create like a number line for ourselves to help figure out this information. So let's use a big long number line here.
So this would be f at 3, right?
Yeah. Here's 16, right? And we know the root of 16 is 4. And then you have, what do we got to get to? 17, 18. So here's our number line. 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so we have all our lovely numbers here on the number line. And what's the square root of 25?
5.
5. Okay, so we know our answer because we're looking for 17. We know that it definitely falls between 4 and 5. The question is, what is it closer to? Is it close to 4.5? 4.5 is probably somewhere in this region, right? Where does 17 kind of fall closer to? 4 or 5?
4.
4. And in fact, it's very close to 4. So what might be a good decimal estimate of the square root of 17?
4.5.
Okay, let's. 4.5 probably ends up around here, right? That's right in the middle of 4 and 5. So what do you think is close?
4.2.
Yeah, 4.2, 4.1. Let's see 4.2. Okay, so that's going to be our estimate. And what we do is we use the symbol. Let's make sure you guys use the same one. Yeah, I use this. So approximately 4.2. I would even say 1, but we can say approximately 4.2, and we can go and check that after, okay? But before we go ahead and check, let's try our 32. Where does 32 fall with our numbers here? Where does it land? Between what values?
Between 25 and 36.
Great. Which means it's going to be between 5 and 6. So I'm going to do the same concept. Okay. And the better I get at this, the less I'll have to draw of a number line. Okay. And let's try to see if we can fit them all in. So 25 will be my first number here. 26, 7, 29, 30, 31, 32, 34, 35, 36. Okay, so we have all our numbers here. We know the square root of 25 is 5. And we know the square root of 36 is 6. And we're looking for the square root of 32. Okay, so this one isn't as close to a value. We can kind of estimate halfway between. Halfway between probably falls somewhere around here-ish, right? We're gonna estimate. And we can, if we really wanted to check, you know, we could kind of eliminate one at a time. Boom. Yeah, so it's going to fall between 30 and 31, okay? So between 30 and 31, what that means is between 5 and 6 is probably about 5.5, okay? So we know that it probably falls somewhere in there. So what do we think 32 might be? What would be a good estimate of the square root of 32?
5.6.
Yeah, something a little bigger than 5.5, but definitely much less than 6. So let's try like 5.6. So let's go up and estimate of 5.6. Okay, and let's test these. Luckily, I have a little calculator I can bring up. Okay, and it does square roots. So our first one, I was guessing 4.1. You guessed 4.2. Let's see what we got here. 4.12. We're both pretty close. Just to brag, I'm a little closer. Yeah. But that's okay. And let's look at square root of 32. Let's see what we got. 5 point, boom. You're like almost right on with that, Okay, so that could be a method for estimating, because otherwise, again, we'll bring up that calculator. They're very long, and this doesn't even justify the whole answer. It continues probably. Okay, otherwise it's a super long process, and the decimal values are so very small, they're almost insignificant. So as long as we can get it to like one decimal place, that's probably a really good estimate when it comes to a square root.